Okay, guys, this experiment is about measurements. And with this said, we have to know how to do sig figs. Whenever we are rounding off those numbers, we have to know the rules of sig figs. Went through that in the lecture. If you are in my lecture, if not, you should have done this one already. So I want to share with you the lab report here, or not the lab report, the lab procedure first. So share. So here it is. This is the file you using it. So open resources. You don't have a book per se in the lab. We have open resources. So what we have to do today we'll have the opportunity to look into measurement and significant figures and some convergence. So the goals of the experiment, and that's what you will do later on when we talk about how to do lab report. So this is the goal of the experiment, has to be your introduction. So you will state those goals in 1 or 2 sentences using your own words. You don't have to copy exact those goals. You just combine those goals in 2 sentences or so. Okay. So I'm sharing this one here. So what we have to do first, we know how to do sig fig. So we'll have the opportunity to look at this ruler here. As you see here, this is in the top, the larger scale is in inches, and the small scales are in centimeters. 1 centimeter is divided in 10 millimeters. So if you see subdivision, we'll be using the metric, not the English inches system. We'll use the metric one. This is the first one. The first thing about the um, ruler here, how to read a ruler here, correct? And as you will see, there will be always a problem to estimate the last digits of the value you are reading. So the first one is easy, straightforward, exact numbers, you can see it, but the estimation of the value at the last digit, that will be a little bit different from person to person. So, and that's what part of the error inside the experiment itself. So then we'll go for a graduate cylinder. We'll have different liquids here. This is a blue one, okay, and this is a green one, and then we'll have different scale. This graduate cylinder is, as you see, 50 mils. This graduate cylinder is going to be 100 mils. So this is 100 mils. Okay, so this is 100 mil, and the blue one and the green one is 50 mils. So we'll do the reading. Now, if you see here inside your inside this one here, it says, I'm sharing this, how to read this one correctly. So in order to read this one correctly, what I'm going to do, I have to put my eyes perpendicular 90 degrees to the meniscus at the bottom. If I'm doing this, I'm reading up higher value, going up, reading up higher value. If I go this below my eyes, there will be lower value. It has to be really 90 degrees perpendicular to my eye. Okay, and there will be always an error of, when it comes to estimate in between the scale, in between the scales. So, for example, you will have to estimate in between. So, for example, this is 58. Now 58. Now it is 58. However, is then you have to estimate in between. I will give it 58.50. So 58 and 0.5. 0.5 is an error. 0.50 is an error. Yes. What's that? There's no Excel tool. Okay, there is one here. Someone is up front. So this is what the error is. Always estimate The exact number is straightforward, but then when in between number, you can just estimate the whole thing. So this is the graduate cylinder. So we know how to use the ruler and read it. We know how to read the liquid in a graduate cylinder. And then that's for the volume. This is the volume here, reading the volume. Then we'll learn how to do, this is not a cube. Okay, so we'll have to determine its volume. So the volume of it will be, you look at this way horizontally, or this is vertically. You can look at horizontally, but it does not really matter. So that will be your length here. That will be your height. That will be your depth. If you look at that vertically here, that will be your height. That will be your length, and that will be depth, height, and length. Right? And the volume will be the multiplication. Okay, the multiplication of those three. Length multiplied by the height multiplied by the width. So those are the whole idea of the whole experiment, is to learn how to use some tools such as a ruler, how to read the graduate cylinder, liquid in it, and how to measure the volume of a solid. Determine this one here, and then determine the fix of this value. So, and later on, maybe today, we'll have even the opportunity to measure the mass of a watch glass and a beaker. So you'll get a small tiny beaker from your glass, from your drawer, and then you will use just the low top balance. And you can use even the other one to compare which one will give you a very good value. You will see here, for example, the top load will give you, I think, 4 digits for sig fix, while the other one, depending on its precision, can you give up to 6 significant figures. So this one here, the flat one, top load one, has 4 sig fix, and this one has the analytical one up to 6 significant figures. So you'll have mass, volume, and mass and volume and the length. So we'll have all those three will determine the whole thing. So here in this, as you can see, just tell you what kilo is. Kilo is 1,000. Deci is 10 minus 1. Cent is 10 minus 2. Milli 10 minus 3. Micro 10 minus 6, and so on. So you can see all those here just to get you the idea how to do some conversions. So this lab is about doing some conversions. We'll do metric to metric. We'll not do the metric to English, but later on you have to be able to do the English to metric, metric to English, and you can do even further metric to SI, international system. So this is the procedure here. We start doing the theoretical one. The theoretical one here, you have to measure here, and then I will come here. You see me here? I'll put this one here, the font. Maybe let me put the font here is 11. I'll put this one here is maybe and then maybe 12. I'll hope 12 will work. So what is the look at this here as we share here. What is the length here is measured? Is what? It's in metric. Remember the ruler here, as you see here, this is the small one here, the upper one. That's the small one here. Each centimeter is divided in 10. Correct? So you have, what's the value here will be? Somebody will help me here. This is for me is 7 point what? 7.2. Okay, I'll take this one here. 7.2. Okay. Somebody will say, well, it's 7.19, correct? Close to that. And that's what the significant figures, always you have an issue with the certainty of the last digit of the decimal. So is it 7.19 or 7.20? So you said 7.2, then I will say 7.2. Oh, you don't have to write centimeters, already in centimeter. Okay, guys, let's look at the second one. Let's look at the second one. So I'm doing this for you. So, and then the rest you can do it in the lab period. So let's go for the second one. So how much is here? How much is here? 1 point what? 9? 1.90, okay. 1.90. Now somebody will say, well, Dr. Atey, how about 1.99? That's you are estimating the last digits. You are not certain if it's 1.9, no, not 99, 1.95, 1.90, so, or 1.89. That's what I meant, 1.89. So I will go for 1.90. Okay. So then you come here. What's the value here? What's the value here? 34 point what? 34.30. Again, that's what you the zero here is a issue. The 30 is an issue because then you have to look into this. I will go for that. Okay, that's my reading. Maybe somebody will read it a little bit of, but the 34 we are agreeing that's the correct answer. Then our issue is how to estimate in between. And the last one, how much is it? 77 point what? 80. I'll take it. 80, correct? So then we come back here, and then we have an object. It's the same thing we have here, guys. This is, you have to write the object when you take, but here you don't have the object. Now, you will do the actual one. You do the what? The actual one. But I want you to do this and yours. So this one here is the width, the length, and the height. So how in the world I will measure this? I will have to have, in order to be really accurate, I can't. I have to print this one out and measure it. Right? But let's see this work. So what I will do, I'll keep everything. If you look at the scale of the Microsoft Word, I will go the slider there all the way to the bottom, make it 100%. Okay, 89. Make it 800. 100%. Now with this 100%, that's the same thing like I'm printing this. Then I'll come here and then measuring those here. So this is the height up. This is the height up. This is the width going through, and this is the length. Although this can be the length and this is the width. The width always smaller value in as the length. So this is the length and this is the width. The width. So you can put this one here and measure. This is in centimeters. Okay, measure those in centimeters in Microsoft. You don't have to print. So the only thing you have to make sure that your file is 100%. That's when you print it, it will be the same thing. If you put it in 100, 200 scale percentage, so you can see at the bottom of the Microsoft Word, there is a scale. So there's a slider there, higher or lower. So make it 100 and measure. So you'll measure length, width, and height, and then the volume will be what? Will be the multiplication of those three. And the unit will be what? What unit is that? You multiply centimeter by centimeter by centimeter. The whole thing will be centimeter cube, correct? Centimeter cube. So the unit here, I'll say, just put a note here. Unit is in centimeter. Centimeter. Let me just make it bigger here, so you can centimeter. What's happening here? So let me take the format out. It's so formatted. It's not accepting this. So Okay, so centimeter, and then you go the superscript 3. That's your centimeter cube. And if you look here, 1 centimeter cube is 1 mil. So 1 centimeter cube, make sure that you understand this. Here, this is 1 centimeter cube. I'm just taking this one here, copy this. 1 centimeter cube is nothing less than just 1 mil. So equal to 1 mil. What it says to us, that if I have a cube, that's its dimension is 1 centimeter in length, 1 centimeter in height, 1 centimeter in depth, the cube will be filled with exactly 1 ml of H2O of any liquid. So, and that's what it says. This is very important. Let's highlight it here, put it in red and put it in yellow. So this is unit in centimeter here. Unit in centimeter, and 1 centimeter in centimeter cube. 1 centimeter cube is 1 mil. Any questions so far? Any questions? So you'll do the dimension, make it 100. You don't have to print it, and then just with your ruler here, the lab ruler, and then you measure the length, the width, and the height. Okay. We'll come to the next thing here. You will have to determine the amount of the liquid inside the graduate cylinder. Okay, the amount of the liquid in the graduate cylinder, as you will do here in this. This is a theoretical exercise for us, but you will do the actual one here. You will do the actual one in those. You will do those in the green and in the yellow solutions here. You will do the actual measurement. So what is the first one? Let's look at the first one. The graduate cylinder goes up. What is the value of each subdivision? What is the value of each subdivision? Come on, guys. What? Point what? 0.1, correct? 2 point, for example, 1.1, it goes, this one will be 2 point, what's its reading? So the smallest or the subdivision is, it is 0.1. So you can do it in red, so it can be shown here and highlight. This is 0.1, correct? So what is the volume of the first graduate cylinder? What is the volume of the first graduate cylinder? It's here. What's the volume, guys? 2 point what? Remember, we are looking at the perpendicular to the bottom of the meniscus. So the bottom of the meniscus is somewhere here. Now, I will say if I have difficulties determine the meniscus and the reading, what should I do? I will go and increase the graduate cylinder sizes so I can see them very well. So I'll come here, the slider, I'll make it, see how big. This is now magnified to 236. Just for case is, I want to see it. So this one is what? 2 point what? Oh, yeah, 2.3. I'll take it. 2.3. Okay, because it's the digits here. Graduate cylinder, you have to have 2 digits after the decimal. So this is, write it here, 2.30 milliliter. Then you can highlight red and yellow. Okay, and then you can even make it bold so it's so the next one. How many subdivision we have? What's the subdivision of those? 1 or 0.1? It's 1. That's correct. So here is the subdivision for each one because you are going from 20, 30, 40, 50. Each of those subdivisions you can see is 1. So it is 1. Then you come here, make it bold, red, and highlight. What is the volume then here? We have just blow up everything up so you can see it. What's the volume? What's the volume here, guys? 13. Everybody agrees? 13. So I have to have 2 digits after the decimal to make it to have the correct value. So 13 here. 13.00 ml. Okay, I'll go here. Bold, red, font, and highlight. Okay, so this one is 12. Have to be consistent with same value. So, third one. What is the subdivision on this? How much? 10. Everybody agrees? 10? That's correct. So 410, 420, 450, 400, whatever. So 10. So the answer is subdivision here is 10. Correct? And I will highlight this one here. Okay, now how much is the value? How much is what's the amount here? So it is 400, correct? And then you have 400, and then this is a 50 there in between, correct? So how much is it? 460. Everybody agrees? That's correct. So this is 400. $460 ml. So I come here. Okay, last one. So how much was the subdivision? Well, that's a subdivision. It's point what? 0.1, correct? Is it? Not 1. 0.1, those subscales. So 0.1. So this is, I can just copy and paste this one here, easier. Copy and paste here. It is basically 0.1. What is the volume of this volume here in the last graduate cylinder? 3 point what? Yeah, 3.9. I'll take it, 3.90. So this one here will be 3.90 ml. So now we have to just hold it, highlight it in red, and so that's the for this graduated cylinder stuff here. So now you will come and read those two here. You will have in this number 4, you read the color of the liquid. One is blue, correct? The blue is, you said blue. You write it blue in this, and then the volume represents each subdivision. So you have a graduate cylinder that is 100 mL. And then from the scale is, this is 90, 100, this is 80. So you have to read what, I'm not telling you the answer. Same thing we did the exercise over there. Same thing with the exercise. You tell me what is, you have to write it there, what each scale, the subdivision is representing. Right? So what you think is presenting? Because it's from 100, from 80 to 90 to 100. So how much is it? Is 1. That's perfect. So it's 1 ml. So I'm not saying anything. You have to do it yourself. And the color of this is blue. And then you have to measure the volume. Read the meniscus, read the volume here. And that's the exercise you do. Then you see the second one is the green color, and the graduate cylinder is 50, and it goes from like 20, 30, 40, 50. So you can see how much is it, correct? So each one is 1, correct? So then you have to read the value. So the first one is the blue solution in this exercise. The second one is the green. Number 4. Any questions so far? That's what you do real first. Oh, because I did for you those I did that for you, correct? And it's in recorded in WebEx. So you have the answer for both those exercises. But this one here, I want you to do it in the lab. Now, second thing here, we have to calculate the mass of a glassware. So you will take, this is 5. Let me save it for you just in case somebody will ask. We can put this one here in the icon so you can see it. Okay, guys. So we did this one here. You will do the liquid, the green one, and the blue solutions there. Here it is. I'll put them back in. So then you have to do the mass. So you will have to have watch glass and a small beaker, not a big beaker, small beaker. You will measure them in the analytical balance in the back here. The analytical balance will give you about 6 fix maybe. That's what you have there. So analytical balance, it has, you have to close the door. It has the windows with glass. See here, this one here. I might take maybe the, let me see here, open this one here. So it is. This is called analytical. And it has glass windows to be closed. Because if you don't close it, the air motion will give you an error inside reading, correct? And then you'll come and then you'll measure the same object, this one here. So, and then it write all the digits coming out, all significant figures, all the digits coming out of your balance reading. Don't around, you don't do nothing, just put the numbers there, okay? So let me get out of this. And so you do it for the two balances, and after you have the value of the watch glass and value of the small beaker, you come up and say how many significant figure for each object, for the watch glass and for the beaker in both balances. You have to determine the sigfix of both balances. Correct, guys? Any question you have? So first we do the volume here, then we will do our volume, and then we'll do our mass of the watch glass and beaker. And I forget about this one here. Remember we said about this? This is whatever you have, but you have to get, this is the theoretical value. This is the practical. You have to take a piece of wood in the back and measure all the dimension and determine its what volume, and write me the number of it. So I have the key for each number here represent how many centimeter cube this value. This is a rectangular, not a cube. So I want to see the number here so I can compare it with the value I have. Okay, guys, so this one here is theoretical, but you have to do what? The actual, this and the actual one. This is the theoretical one. The same thing we did here. We did that theoretical one, but you have to do what? The actual one, correct? And the masses here, we have to do the actual one, which is the mass of a beaker in both balances, top load and analytical, and the mass of the watch glass. both balances, analytical and tableau, correct? So and then you do the significant figures and everything. Now, here, now we are switching here to sig fix. And I'm not sure is how many of you take significant figure in the lecture. Raise your hand if you have taken sig fix already in the lecture. Okay, the majority. Okay, the majority. Good. So then you help me here. We'll do all those here quickly, just not all of them, but at least we'll do some of them. Okay, so let's do J. J is 3.440 10 power 4. How many sig fix we have here? How many? 4. Okay, that's 4, correct? How many H? How many H? 2. That's correct, 2. How many F? 3. How many D? 7, correct. How many B? 5, that's correct. Okay, so I think we got how many this is I think this is I. How many I? 2. How many C? Not 2, 4. Okay, so you get the idea. That's very good. So let's take this one out and come back here and look at the rules of addition and multiplication. Here's give you what is give you the let's put this one here as a pencil, not a marker here. So when you add subtraction, it will the least digit after the decimal will control the outcome, correct? So how many digits we have here? How many digits here? How many digits after the decimal? Now, 2, correct? I can write it here. Let me just take it and type it maybe. So this is 2, correct? 2 sig fix. And this one, how many? Not 2 sig fix. Okay, sorry about this. We are looking at the digits. That's addition and subtract. 2 digits after the decimal. And here, how many digits we have? 3 digits after the decimal. And here, how many? 1 digit. So the least will win. And this will be highlighted. This is 1 digit. That's the one will win. The 1 digit will win. So your answer has to be what? 1 digit after the decimal. So you have to stop here. So I'll stop here. So this should be my answer, correct? However, I have 8 after the 8. So it will be rounded as what? As 1. And the answer is and the answer is the answer is 16.9, correct? And I wanted to fill this one here all the way. We'll have 1 week to finish this lab and submit it as is. So this one here does not have per se. We can do it as a lab report. So I'll show you how to do the lab report. So now the conversion here. The conversions here, you have metric to English, like here you have, if you look at this one, guys, this one here is 2 system, metric to English, okay? And then you have metric to metric, okay? Metric to metric. And here is metric to English. Okay, so and again, the other one is metric. The third one is, the first one here is metric to metric. So the conversion is very important to know. As I said, when I give you the quiz, you have my permission to use OpenBook. So you have my permission to download the chart or a table that will help you to convert those back and forth. Everybody's following? So that's here an example here. And always the key of this is unit cancellation. If the units are not canceling, then something wrong in your calculation. Let's do here, come here and see one example. It said 333, and that's what you have to do. That's the conversion you have to submit as part of the, after the conclusion, you have to submit those questions here. Let's do this one here. Here it is. 333 mLs. How many in quarts? So what should I do? I start with, I can do it here for you, tabbing the whole thing. I'll start with, here it is, 333 ml. Okay, then I have to get rid of the ml. So I put the relationship is 1 QT has how many? 96946 ml. So the ml with the ml cancels out. This ml here will cancels out. And this ml here will cancel out. And then whatever the value here, you can calculate the value here. So I have 333946. Every one of those is 366. I'll come back here and then I have my calculator here. I hope it's working. Calculator. See, here it's working. So I'll pin it, but in that room is not working. So I'm pinning it. So calculator. I have to pin into taskbar. So I have 333 multiplied by 946. This is, the answer is, just hold on. What I will do, I just copy and paste the answers. But this is copy and paste the whole thing, copy and paste. This is the answer. This is in, correct? Yes. Oh, divide. Yeah, I made a mistake. Yeah. Thank you for bringing this. So it is here. Yes, CE means clean everything. Clean everything. C is clean, and C is clean everything. So here it is 333. Yes, you are right. Now divided by 946, and it has 333 divided by 946. I hope it's working this. So I'll put the same value as is. Nothing rounding off, nothing do nothing at the beginning. So I have pasting here. Paste. Yeah, it does paste. So that's the answer here, guys. That's the answer here. So I need how many sig figs? 3 and 3. The least sig figs is 3. So I will stop here. All of them here. Well, it's nothing. So, but anyway, so I will take it here from this is 0.352. There is here 0, so I'm not count. There's 0 here. I'll highlight it for you here, make it. That's 0, it's not counting. So the answer is 0.352, and the unit is QT. Okay, guys? So you will see all those type of question is just unit cancellation, use the correct conversion factor, and then observe the sig fig rules. Okay, guys? So now you did all this conversion, you can do those. And if you have any question, come and see me, I'm here. And then you do the lab report. Will not follow this lab report here. Not follow this lab report. We'll have to have our own lab report. So I have for you here, let me minimize this one here for the time being, minimize this, and go for the density here. Here it is. This is the lab report. You don't have to write your name here. No need for the name. So just leave it here. So you will submit your lab report in a way. Let me share it. Let me get out of this and share the PDF. So I'm sharing the PDF. That's a lab report for next week, but you will do it for this lab. So how we do it? Well, the experiment is experiment number 1. It's about the measurements, correct? Today it's about measurement of sig figs. So introduction. Somebody will see what's the goal of the experiment. The goal of the experiment is stated in the this one here already. If you look at this, I think we have it all the way in the top. That's the goal of the experiment is there. So I'm going all the way up. That's the goal here. Okay, that's the introduction. Just read this one here and summarize the whole thing. So I'll tell you this just from just looking at this without even details. What we have done, what is the experiment is all about? The goal of this experiment is to have the sense and the measuring of the mass, the volume, correct, and the length of an object. So we will the volume of a liquid, a galvanized cylinder with different dimension will be red, and the mass of glassware will be examined. We did with the watch glass and the small beaker, and then we have to use the ruler to determine the dimensions of an object. In this case, we did it theoretically there, and then we'll do to that object. That's it. That's what the whole. And then in all these processes, we are learning how to use the sig figs, to apply the sig figs in this measurement. Furthermore, we have to look into the conversion from metric to metric, or from metric to English, and vice versa. So without even looking at this, that's what we have done, correct? Okay, so that's the introduction. The procedure. So then you come here. Let me go back to the, this is the procedure here. So the procedure we did, what we have done. We have done for example, the volume, the theoretical one on the sheet, on the lab procedure. We did the theoretical one with the different volume at different sizes of graduate cylinder. We measured the volume and the subdivision volume, correct, or value. So then this is for the volume. Then we went to the procedure. We went and measured the theoretical dimensions of an object in the procedure, as well as the real object with the real object, and determine both, in both cases, the theoretical one or the virtual one on the the procedure itself, and here the real one, we determine the volume in centimeter cube, correct? And then we have measured the watch glass and the beaker using two different balances. So the one top load does not give us a very good precise values, just 4 sig fix, and the other one 6 sig fix, which is more precise and give us even better precision and better accuracy, both. So that's the procedure. Okay, then you'll come here and the data. Your data are from whatever this. So your data, what you will do, you just come here, and then what you will do here, copy. So I'm copying the whole thing, putting a new, this is my, let me do here, let me just switch now. I'm switching to, let me switch, share, Microsoft Word, share. So now I'm doing my blank, brand new one. So then at this first, the introduction, I stated the goal of the experiment, introduction. So I state the goal of the experiment, okay? And then the introduction, the procedure, sorry. The procedure we did whatever we did in the manual procedure, the experiment. Now, the procedure, you have to use your own words, so your own words. So don't copy, because this one here, so if I get this one here, there, so look at this. This is your procedure here. You have measured all those here, just your own words, correct? So you measure the distance using a ruler, okay? So you just type here just what the procedure is, measuring a distance using a ruler in a metric unit or scale. That's one. Then what you did, you measured the volume, measuring volume of different graduated cylinder. Cylinder here. And those are manually and virtually and on the lab. So we did the manually on the lab procedure as well. So here, virtually on the lab procedure, as well as manually in the actual lab. So we did the gas cylinder here with the actual lab with green and the blue solution kept in different sizes of graduate cylinder. So, and so on. Then you say measuring the mass, watch glass, and the beaker. So I'm measuring here, correct? We did this one here. We did using the distance different. And then we measured the scale here, correct? The distance scale, as well as the volume here. We did manually, we did the virtually when we measured the rectangular depth and length and height. So then you can measure the mass, correct? Measuring the masses of watch glass as well as a beaker using tab load. Tab load does not like tab load by itself, so tab load balance as well as analytical balance. Okay, guys, so that's the procedure here. Then when it comes to my data, okay, my data is coming from the experiment. My data is, okay, so data here, I'll come and look at the data here. That's first my data. I put the numbers here, copy them, and copy this, and come here, data results. That's the first my data, correct? Don't worry about the figure. It does not take the figure, but that's what your data is, correct? You can sometimes, it's just sometimes it does not want to take the figure. So the best thing is what I'm gonna do to do right, correct. Somebody will tell me there is a snipping tool in the bottom of the search here. Search for snipping tool, snipping, SNIPPING. Here it is. I click on that, correct? And then I will pin it. So every time I don't have to search for it. It's pinned to taskbar and pin it. So now I need to have everything in details with all the colors and everything. So here it is. I'll take the whole thing here. That's easy. So take this and then edit, copy. Then I come to my lab report. And here it is, guys. This one I don't like. So just redo this one here, and then I will paste. So I paste the whole thing. I don't know why it came out to be, well, sorry. Why it came out to be, yeah, that's, I don't like the shade. So let's take it without the shade. Let's take it without the shade here. So here it is, copy. And I am going to the procedure here, guys. And that's my procedure here. Don't like the shade, so I delete this one here. Delete. Delete, and then paste the one without shade. So now here I have all this one here. I come next is to the next one here. We did what? We did this one here, correct? I did not measure those. You have to have it 100%. So suppose this is 99%, so 32. That's 100%. So I did this measurement here. Then what I will do, I'll just come here. I don't have to write all this one here, but I will say a new. I will take first the object. Okay, so first the object here. It's you can do it. It's just taking a little bit of space here. So the object here, copy. That's the second one, and then come to my. This is the second one. Correct? No, not this one. Where's my? Yeah, this one is mine. So I come here, and then the next is enter here. So the next is this one here I did, and you can make it smaller if you want to. Make the font. I mean, you can make to size the sideways layout, and then you can do whatever you like. 1:1 is too big. Let's make it smaller. So now I have it small. So 0.5 inch in both sides and top and the bottom 0.5. So I have it That's number 2, correct? Then the volume here, I'll come and copy and paste the volume here, calculate. So the volume of this is this one here. So the volume is whatever the height and the length you have. So here it is. You can take, copy and paste all this stuff here, copy, and then come to your lab report here, and then just suppose the length is, I don't know, suppose the length is, say, 2.5 centimeter, correct? And the width is maybe 1.2, 1.5, correct? And the height is 1.5. So then you'll see, then you don't have to calculate, so just take this one here, say volume of the solid, volume of the object above is whatever is multiplied those three, 2.5 multiplied by 1.5 multiplied by 1.5, how much in centimeter cube. And then you will say, that's the virtual one. Then you can take a picture of this, or just, I have a wooden object, the volume of the wooden object, here it is. Take the whole thing, copy. Now the numbers are now here is home, paste. That's, you say here, that's for the actual one, for the wooden object dimensions. So you measure all this here, and the number of this, oops, object here, wooden object, you have to put here number, what's the number? Number 32. Number 32. Okay, so whatever the dimension here, you measure it, will be not the same like the vertical one. So you measure this, this here, okay? So then you have to come up with volume of the virtual. This is the virtual object. Virtual object. Virtual object above. So when somebody will read, that's above. Then the volume of the wooden object is number 32. So then you'll see here it is. Copy, paste here at the bottom, paste it, and then paste the volume of the copy, paste. You don't have to say virtual now, just above. The dimension above is whatever the numbers are. You multiply those number length, multiply by height, correct? The same thing here. So here it is. And then you come up with centimeter cube, whatever the number is. So the next, that's you'll do it at home, not here. I want you to do the measurements and do everything at home. Then you come and then make copy of this. You don't have to do all this one here. So what you will do here, so if I do, I need to squeeze it, this one here, so I can squeeze this one here into this. So I can make it smaller. Let me see, maybe smaller. So I want to get this one here up. So try to get this, but it does not matter. I can say the next is measuring the volume of a liquid. Next step is measuring. You type, you can have this one here, copy it into the okay, here will come new topics here. That's the volume of this, measuring liquid, and then you just snipping tool. You snip all your data here. You have them. You wrote this one, your data already. You just snipped one at a time. So I'm snipping this one here. I did the data already. So just snip it there, copy it, then put it in my lab report. So paste it. And then paste the values there. I had it, so there. I had the values there. So this is my answers there, just new. Okay, so copy it, edit, copy, and then paste this, paste. So, and then you will do the same thing with the watch glass, copy and paste, and then this is the virtual one. Then you will go here, and then the same thing you did for the one is here, correct? So you will do just copy and paste all the stuff here. Okay, so one at a time maybe. Copy and paste, or you fill this one here, and then you copy and take snipping tool to snip all your data, whatever your answer is, or you can type it. I mean, you can put the whole thing here, and let's see if I can take it here. So copy. If it's not doing, then you can answer the whole thing inside and snipping out with the snipping tool. So here it is. This is here, guys. So I have the graduate cylinder one. It does not take the one here, maybe. Let's see. It took the one, it did not take the second one with the copy and paste. So the best thing is then you have to fill it inside and take this snipping tool. You have to put liquid is whatever the color is, blue or green. Fill this one here. Okay. So here it's coming here, say this is blue and this is green. And then you determine the volume amount of each of solution, and then the volume of the liquid and the subdivision. So when you are done, then take the snipping tool and then snip the whole thing inside your data here. And then you'll do it the same thing for the masses here. So you go here, fill all your data in, here, correct? So all your data in, you'll fill it. It is, guys, fill all the data here, whatever the mass of your watch glass, using the two different balances and the peaker, two different balances. Snip it, and suppose now I have all this data. I did not fill them, but suppose I have all the data, come and then snip the whole thing here. Okay, guys, that's it. That's all my data I need. Don't worry about the other stuff, significant figures. You can do it for yourself in the other one. I'm not interested to see those exercises. You can exercise those, but that's the way you can submit. It is that's the mass. This is your procedure. Then we come to discussion. Discussion how you did well. You did very well, because still you can't say that my digit, the last digit estimation might be off, depending on my reading. Otherwise, all my readings are correct to the best. And then you can discuss that when it comes to the balance. Analytical one will give you better reading. This one here, you have problems with this to pinpoint the exact meniscus, and that's what give you an error. So, and the ruler will not give us the best measuring. It's not the best measuring tool. It's a very good tool. And then conclusion, you go to discussion, to the introduction. The discussion is connected to introduction, how you did. So let me go for the density now to show the density. Let me switch to density here. And that's the last thing here. Let me share the density here. Okay, share it. Now you can see that's the measure. This is the experiment of density XP. But this is what this is all about. This is the introduction. What's the procedure we are doing? We'll do part 1 and part 2 in the procedure. State this one here in your own words. This is the collected data you collect, correct? And what's the unknown liquid is? That's the unknown liquid data. And then you do whatever dimension method, whatever all your calculations. That's your discussion. And that is your conclusion. And when you are done with this, you go to the assignment section to iCollege and you upload this one here. So if I stop sharing, let me share the iCollege. It is, I hope I have the iCollege here. Well, that's the screen. But anyway, so this one here has to be submitted into the assignment. Any question you have? I spend longer time because that's the way we'll set up our all experiments. So the experiment itself will not take them 15 minutes. Then you are done because you are measuring just this, correct? The other stuff you can do it at home, and you have some of there. I'll just posted them for you. And the watch glass. So watch glass, the beaker in 2 balances, reading this, measuring this, and you are done. Should not take half an hour. Everything's following? But I took more than half an hour to show you how in the future we'll follow. So what you have to do, reading those two are blue and green, measuring the dimension of this, and going inside with the top load and the analytical balance. That's all. 30 minutes, I'm expecting everybody will be done and everybody will hit the highway. Literally, not hitting the highway. 30 minutes, you should be done. But I spend a lot of time going through this because that's the way it is. It has to be clear for the next labs, how to write technical lab report. Any question? Yes, hold on. Conclusion, you always connect yourself to the introduction. The PDF, that should be inside the you go to iCollege, all the folders are, it said lab reports, the folder in iCollege. Okay, so I will stop here recording here. Any question you have? So I stop. This is how to do the actual experiment number 1 and do the lab report. Next time, I'm not spending that much time. I just go to the procedure because this time took me a lot of time to explain how to write the scientific lab report. So